So when we are multiplying numbers that have the same base, multiplying them, whatever they are, to the power of this to the power of that, as long as they have the same base, you can just add those powers together. And that is that's the index law for multiplication. The index law for division is just the opposite. Again, we have the same base, number, letter, and if we have these two powers, we're going to end up just subtracting them, and I'll show you why that works. So simplify giving your answer in index form. So 3 to the power of 6 times 3 to the power of 3. Do we have 3 to the power of 4, rather? Do we have the same base? We do. So that's going to end up being 3 to the power of, we're multiplying 6 plus 4 equals 3 to the power of 10. And why does that work? I'll show you below, but I have 6 of those 3's that I'm multiplying and 4 more of those 3's. It adds up to 10 of those 3's that I'm adding together. For this example, I've got 7 to the power of 9 divided by 7 to the power of 5, and if we use our second index law, that is going to subtract the two powers from each other, leaving us with 7 to the power of, 4. And again, I'll show you below why it works, but essentially that's the rule. That's all there is to it. I'll make that a little neater. So now, simplify each of the following using the index law. So again, I don't have a number, but I do have the same base of x. So x to the power of 4 means I've got 4 x's, and I'm going to multiply that by another 5 x's. So that means I've actually really got x to the power of, adding those indices together, 4 plus 5 is 9. This one looks a little bit more complicated, but really it just means, I'll write it out, x to the power of 3 times y to the power of 4 times x to the power of 2 times y to the power of, I don't know, I have to figure it out, I think you know. So if you look at it in a different order, I can put those x's together, and I've got x to the power of, I'm multiplying, so I'm going to add them, which is going to give us x to the power of 5. And then next to that, I haven't finished yet, times the y's. So the y's are going to be, what am I going to add? 4 plus y to the power of, if it's just y by itself, it's actually to the power of 1. So that gives me y to the power of 5. And I don't need to put a multiplication sign in between there, because it just is what it is. So that's x to the power of 5, y to the power of 5. Now this one, again, it looks scary, but really it's just 3 times m to the power of 4 times 2 times m to the power of 5. And so if we reorder that, I've got 3 times 2 is 6, because I can just multiply those numbers together, and it's going to end up being m. I'm multiplying, so I'm adding 4 plus 5. So the real answer is 6m to the 9. Now these ones I'm going to show you a little bit drawn out, but I'm going to show you how these work. Simplify each of these by using the index law for division. So this is really going to be x to the power of 10 minus 2, which equals x to the power of 8. That's true. That's how it works. How do I know that that works? Well, let's look at this one. So this is a to the power of 6 means, I'm going to write it out for you. I've got 6 a's. And I've got 3 b's over 12 times 2 a's and 2 b's. So I've just written these out. I've expanded the form. And the only reason I've done it is so I can show you sort of why this works. Sure, the simplest thing to do would be, let's see, let's cancel this out. Divide both of these by 4, and I get 2 over 3. That's right. And then I would do, for the a's, I would do a to the power of 6 minus 2, which is 4. And then for the b's, b to the power of 3 minus 2, which leaves me 1b. But let me illustrate that. I'm going to cancel. So all the a's are gone, and I'm left with just what I said before, 2 times a to the power of 4. And then I cancel the b's, and I've only got 1b left on the top. And so that is our answer. 2a to the power of 4 times b, all of that on the top, all of that divided by 3. Now for this last one, simplify each of these using the index laws for multiplication and division. So of course we're going to do these in the order that they are set out from left to right in the order of operations. So this is x to the power of 2 plus 3 divide x to the power of 4. And so that is x to the power of 5 dividing x to the power of 4. And I'm sure you can see that my answer is just going to be x, because I would subtract them, 5 minus 4, and I don't need to put x to the power of 1, I could put x. But remember, if I'm dividing them, I could do x, I'll use a dot for multiply, you'll see that at some point in your lives, times x, divided by x times x. I've got 4 of them on the bottom, then you can see really clearly that I'm going to end up canceling out all but the 1x on the top. And so for the one on the bottom, I'm just going to do the same thing. I'm going to gather all my terms together. So my numbers 8 and 2 are 16. I've got a to the power of 3 times a to the power of 2. So that means a to the power of 5 because I've added up the 3 and the 2. How many b's do I got? I've got 1b, b to the power of 1, b to the power of 3. So that'll be b to the power of 4 because remember there's a little 1 in there. It's just a little. And then all of that is going to happen over top of 4, a to the power of 4, and b to the power of 2. So now all we got to do is take 4 out of each of these, and that becomes a 1. A to the power of 5 divided by a to the power of 4. So I've got 4 on the top. And that gives me a, because I'm subtracting 5 minus 4. And then b to the power of 4 divide b to the power of 2 is subtracting 2, and that gives me 4a b to the power of 2.